Hey guys, Mr. Milton here. Today we're going to start our first lesson on advanced word problems. At the end of this video, you should be able to rewrite a variable in terms of a second variable, and you should be able to set up and solve word problems involving two variables. Okay, in the last few lessons, we'll be setting up and solving more advanced word problems. The first example is below. The sum of three consecutive integers is 147. Find the three integers. Okay, this is saying that there are three unknown numbers. Saying that three unknown numbers add to 147. We say add to because it says the sum. Keyword there. Okay, therefore the equation we can get from this is x plus y plus z equals 147. However, we have no way of solving this since there are three variables. Okay, we talked about this with literal equations. If there's more than one variable, we can't necessarily solve it. We can isolate something, but we can't get a definitive answer. But this problem is definitely asking for a definitive answer, so we need to fix this problem. Okay, in order to fix this problem, we need to find a common link between the variables. So that we can write each variable, in this case y and z, in terms of another variable, in this case x. So here's how we're going to think about this. Keyword, again, consecutive. What does consecutive mean? It means it comes right in a row. So even though I wrote it initially as x plus y plus z equals 147, I know that they're consecutive. So if I think of y, how should y relate to x? Well, it's the number after x. Is there a way I can rewrite y so that I don't have to use a different variable? Yeah, since it's the number after x, it's x plus 1. Right? It's the number after x, so x plus 1. That makes sense. Okay, z can also be written in terms of x because it's the number after x. So we can write that as x plus 1, which will be easier to write as x plus 2. Whatever x is, two numbers after that, that's what z is. Okay, and this is what writing a variable in terms of another variable means. Okay, I know that z is a whole different number, but because I can find a common link, because I know it's a consecutive integers, then I can continue using the same variable. And that helps me because now I have a problem that I can solve. Okay, as I solve this or simplify this, I can, on the left side, get x plus x plus x, which is 3x. 1 plus 2, which is 3, equals 147. And a problem that we start off not knowing how to solve because there was too many variables, we now have a problem that's able to be solved. So we have 3x plus 3 equals 147. And we solve for that. We subtract 3 from both sides. We get 3x equals 144. We can now get x by itself and divide by 3. And we'll find that x is 48. Okay, and so now our beginning problem where we had x plus y plus z, might as well just say x plus 1 plus x plus 2 and find our numbers. 48 plus 48 plus 1, which is 49, plus 48 plus 2, which is 50. Alright? So, the sum of three consecutive integers. Let's try this again with a different problem. Three consecutive integers is 2,730. Okay, this is the same exact problem. So we can go through the whole logic and reasoning again, but I'm just going to say, okay, x plus 1 plus x plus 2, so my three numbers, my first number, my second number, my third number, equals 2,730. I simplify this, and that gives me 3x plus 3 equals that number. Okay. Finish that, solve that, give me the solution for that. Okay. Actually, scratch that. We'll give you the solution. I'll let you do this one. Okay. So let's finish this since I already have it set up. 3x plus 3 equals 2,730. Subtract 3 from both sides. We get 3x equals 2,727. And then we'll divide by 3. And we'll get x equals 909. So it says find the integers. 909 would be the first. 910 would be the second. 911 would, 911 will be the third. I'm going to scratch that out and just write it. Alright. And you can always check these numbers to make sure in your calculator, does this add up to what I'm looking for? And we see that it does. Okay, so there are checks for these. Okay. Final question, couple things that I'm going to let you know before I send you off on your own. Notice the differences here, guys. They're asking you for 4 consecutive integers, and then they're telling you to find the largest integer. So just pay attention to that. Pay attention to those two things as you do it. Should be the same reasoning as you go through it. I'm interested to see you set that up. All right. On the back side, let's look at this problem. It says the sum of 3 consecutive even integers is negative 72. Find the integers. Okay, and so to do this, first of all, evens are already underlined, so I'm not going to underline it again, but notice that that's the big difference here, is that this is talking about even integers. So what we're going to do is we're going to see how we would write those down as variables. So let's write any even numbers that we have on the line. I'm going to just say 6, 8, 10. Okay. What do you notice? They increase by 2 each time. Okay? They increase by 2. So the first integer is x. What will the second integer be? Well, let's say that this is x. How would I get to 8? Well, I'd take x and then I'd add 2. Okay, again, let's say that 6 is x. How would I get to 10? Well, I'd take x and I'd add 4. Or I'd take 8 and add 2 more. So x plus 2, which is x plus 4. Okay, and so now we're setting up the problem that's just a little bit different, just a little bit differently. X, the first unknown, plus x plus 2 plus x plus 4 will equal negative 72. Or 3x plus 6 equals negative 72. And so now we can solve it. Make sure that we do the math right. We get, move it up here, 3x equals negative 78. Divide by 3 and we'll get x equals 26, negative 26. Yep, that looks right, 26, yep. Okay, and now we'll find out what the integers are. We take x, which is negative 26, plus 2. So really important here, guys, that this is x plus 2. That's going to give us negative 24. X plus 4, which will give us negative 22. Alright? And then again, you can try that out if you need to. 26 plus 24 plus 22, all negatives, negative 72. That's what we're looking for. Okay. Quick question here. Or at least similar question. The sum of 4 consecutive odd integers is 344. What is the largest integer? So again, we're going to look at this because this is odd. This is different even than even a little bit. Okay, so let's write any 3 consecutive odd integers. I'm going to go 7, 9, 11. What do you notice? They also increase by 2 between each integer. If I was going to say this is x, this would be x plus 2. This would be x plus 4. So even though they're odd, or because they're odd, a lot of people are tempted to make them increase by 1 and then 3 and then 5. But notice that odd integers are 2 apart, just like even integers. So our first term would be x, our second term would be x plus 2, our third term would be x plus 4, our last term would be x plus 6. You can write that out each time if you'd like to, or you can simplify it by yourself if you want to as well. I like to write it out just so I have it down. X plus 2, x plus 4, x plus 6, and see I have one term, 2 numbers, 3 numbers, 4 numbers. I know that. Now I add all my terms together. I have 4x plus 12. 2 plus 4 plus 6 will equal 344. Okay, and so now I have an equation to solve. I'll subtract 12 from both sides. 4x equals 332. Divide by 4. X equals 83. Okay, and now it's asked me for the largest integer, and so I'll say 83. That's my first term. That's x. 85. 87. 89. So to answer the question correctly, 89 is the largest integer there. So since consecutive integers look the same as consecutive odd integers, what is the difference between them? The only difference, and this is what you should check each time, the only difference is the final number. Okay, you should make sure that if it says odd integers that you're finding an odd integer. If it says even integers, you're finding an even integer. Okay. Consecutive integers are not the only types of problems that require rewriting a variable in terms of another, but they provide good practice for the skill. Below is another example of when this skill is needed. So let's look at this. Roger cut a 200 centimeter board into 2 pieces. The larger piece was 5 centimeters more than double the shorter piece. What are the lengths of the 2 boards? So here we go. We have 200 centimeters. We have a larger piece and a smaller piece. When we put those together, they are 200. It says the larger piece, I'll just use L, was 5 centimeters more than double the shorter piece. We'll say 2s plus 5. What are the lengths of the 2 boards? So what we do here, as we look at this, we actually have kind of already rewritten our variable in terms of another variable. Notice by the description they gave us, if we were trying to solve the lengths for this first equation, we wouldn't be able to, because L plus S equals 200 just doesn't help us out very much. There's 2 variables, 1 equation. Here, by itself doesn't help us either, because we have, again, 1 equation and 2 variables. But this says that the larger one is 5 more than 2 times the shorter one. Since we have a common link now, I can change this equation. And instead of writing the larger one here, I can say, well, that's the same as 2 times the shorter one plus 5. Right? Those two are the same things. That's what equal means. So I can rewrite this as, instead of L plus S equals 200, I can say 2S plus 5 plus S equals 200. Okay, or I can say, I'll just keep it as here, 2S plus 5 plus S equals 200. Make sure your S's and 5's are different. Maybe S was not a very good variable, but I can tell the difference. Okay, so now as we solve this, we have 3S plus 5 equals 200. I subtract 5 from both sides. I have 3S equals 195. I divide by 3. I have S equals 85. So the shorter board's 85 centimeters long, and the longer board then would be the rest of that 200, which is 115. Okay. All right, so there's some practice in writing a variable in terms of another variable there. Um, Practice that skill. Make sure you complete that practice problem for me on the front, and I'll see you tomorrow when we're doing these.